What I'm going to do is present briefly the summary of the benefit cost analysis that we had VOPI do for my agency, which is not NHTSA, it's not the National Highway Traffic Safety Administration, but the Federal Motor Carrier Safety Administration. And we did look at side guards. And the reason we did this was I had an interest in seeing whether there was a synergistic effect between an aerodynamic design of fuel saving and side guards for lowering or mitigating fatalities due to bicyclists and pedestrians crashing into trucks. Now, before I begin, I need to tell you maybe the final answer. Yes, side guards for preventing fatalities from crashes of pedestrians and bicyclists with trucks, okay, is cost effective. All right, so there you have it in a nutshell. So I'll go through the benefit cost analysis quickly. Okay, the first chart I'm showing you is the number of crashes per year between 2005 and 2015, where fatalities due to side guards can be prevented. They're actually the number of fatalities of crashes of bicyclists and pedestrians with the side of trucks. And the blue represents what we call combination trucks or semi-trailers or a tractor and trailer combined. The red bars represent the number of fatalities per year that result from crashes of pedestrians and bicyclists with what we call single unit trucks. These are trucks that have one single platform or one single body. Now, the trucking industry did not like this chart because it was counterintuitive. They objected to it because it showed that semi-trailers, that is tractor trailers, have at least as many, and in most cases, more deaths from these crashes, single unit trucks, which are shorter. And it was counterintuitive. I didn't expect that either, but VOPI found that when they went through the crash analysis. Now, VOPI did do a literature search, a literature review. This was published, okay? Not the entire report. They just took the literature review and published it. And it's posted as the final report on the DOT website. The majority of their literature reviews, okay, studies show that side guards on trucks show that they are effective in mitigating crashes with bicyclists and pedestrians when they're traveling in the same direction. Few of these studies were inconclusive, but there was no study that disproved side guards' safety effectiveness. Okay, now why do we want to look at aerodynamics around a truck? All right. Well, these figures, these graphs, show you the wind tunnel effects of a truck going in the forward direction with wind resistance or air resistance. And you see in the top figure, okay, a truck without an aerodynamic treatment. There's what we call the vortex or wake behind the truck and also underneath the truck. Now, in the bottom figure, you see a truck that's been aerodynamically treated. It's got what we call a boat tail at the end of the truck to prevent the vortex so that the air flows smoothly. And there's a skirt, is kind of paneled or blocked out between the wheels that makes the air flow kind of smoothly or in a streamline around the wheels. So there's a benefit of having side guards that are aerodynamically designed because they save fuel. And air resistance counts for something like 50% or more of the power to move the truck at highway speeds. We're talking about 55 miles an hour and more. So there is a benefit, fuel savings benefit to having aerodynamically designed side guards. Okay, now there are such things as aero skirts, skirts that are put on the bottom of a truck to streamline the flow of air around the wheels or tires. And they're just called aero skirts. Now, when these skirts are reinforced to act as side guards, then we call them aero side guards. Actually, side guards that are aerodynamically designed, and they give you the fuel savings. Now, these aero skirts or aero side guards, they do not prevent underride of cars. They only prevent underrides of bicyclists and pedestrians. Okay, these panel aero side guards can be put on what we call single unit trucks, which you see on the left. They go, of course, between the fuel tank or the cab and the rear wheel. And they can be put on the trailers too, of what we call combination trucks, between the wheels of the cab and the rear wheels of the trailer. All right, now we get to the benefit cost. All right, aero side guards that is side guards that are aerodynamically designed and prevent fatalities of bicyclists and pedestrians crashing into the side of the truck. Okay, this shows their cost benefit when they're fully deployed by 2045. Okay, the year of implementation is 2020, which we know is past. They're all installed by actually it's 2040, because it's 5% of the trucks installed per year, and then they allowed 5 years to see what would happen. Okay, now the costs are in green bars, kind of reach a peak around 2027 and then drop off in 2040, because it's when all the side guards are put on. The safety benefits increase and they peak out around 2036, and then they lower. The aerodynamic benefits peak out earlier, 2027, and then keep dropping, because almost all the trucks had them by 2040. Okay, let's go on. Now, how do they calculate the benefit cost ratio? Okay, the benefit cost ratio is defined as the total benefits divided by the total cost for a given scenario. Both be looked at 3 scenarios. First, the total benefits are equal to the safety benefits plus the fuel savings. Okay, safety benefits calculated by looking at the reduction in cost in crashes between bicyclists and pedestrians and the trucks with side guards. The DOT assumes that the value of human life is $9.2 million. That was way back in 2017 when they did the study. Okay, so normally we don't put it, we value human life as invaluable, but they had to put a cost on it. All right, how do they calculate fuel savings? Well, it's the reduction in fuel consumption, the cost of fuel, by the percentage of trucks with aero side guards. And they assumed a speed category of miles per travel for each category of truck. I can't go into detail here, but table 10 means that these numbers were calculated or summarized in table 10 of the final report. Total cost equals the cost of the side guard, that's the equipment, plus the installation cost, plus the maintenance cost. The original equipment manufactured cost of the side guards, that is aero side guard panels, are about $1,000. This is back in 2017. The cost of installation ranges from $700 to $1,800 for what we call rail side guards, and $1,000 to $2,700 for a full panel arrow side guard. Now, in the cost benefit analysis, it was too complex to use this range. So what they did was use median figures. That's the midpoint of the range. All right. Midpoint of the $700 to $1,800 rail side guard is $1,250 for the retrofit, and the median of the $1,000 to $2,700 full panel arrow side guard is $1,850 for a retrofit. The annual maintenance is very cheap. It's $7.27. And that's because all the technician has to do is to look at the arrow panel guard and see if it's been damaged. If it's not damaged, there's nothing else done. Okay. Now, what do we mean by the benefit cost ratio? Well, when the benefit cost ratio is greater than 1, that means the benefits of the side guard exceed the cost of the side guard. So we call that, the economists call that cost effective. When the benefit cost ratio equals 1, that means the benefits equals the cost. So that's a complete wash. Okay. When the benefit cost ratio is less than 1, then the cost of the side guards exceed the benefits. And we call that not cost effective. So now let's look at the compilation of results table, which define or give you the results of the cost benefit cost analysis in terms of the benefit cost ratio. And you notice in every case, it's greater than 1. In other words, the benefits exceed the cost, all right? And they're between 4.65, and the lowest number we have here is 1.19. That's for the 3 scenarios that Volpe looked at. Now, the benefits and the costs were discounted at 7% a year. In other words, we were, well, Volpe, anyone who does a cost benefit analysis for the government has to discount future benefits by 7%. Now, these are given in a range. That's when the benefits are considered high, and the lower end of that range is when the benefits are considered low. Okay, there is a range. Then when these were translated into actual dollars, you see the total net benefits. The highest is $61.6 billion of dollars. The lowest is $42.2 billion. Okay. And with the arrow side guards fully deployed, the total net benefits are $2.7 billion. And at the low end, it's $0.40 billion. Okay, what's the payback period for each scenario? Discounted as 7%. For the first scenario, which is deployment, full deployment, all the trucks put these side guards in the first year. The high benefits payback is in 3 years. The low benefits are 4 years, a little bit longer. For gradual deployment, that's 5% a year. Okay, and then all the side guards are fully deployed at the end of 20 years. It takes 6 years for the payback to. That's with high benefits. For the low benefits, it takes a bit longer. That's 8 years to get that payback. For arrow side guards fully deployed, 6 years. For high benefits, 18 years for low benefits. Okay, what are the conclusions of the Volpe report that you were not allowed to see? And it was suppressed by DOT. In all scenarios studied, the benefits are greater than the cost of the side guards. In other words, the benefit cost ratio was greater than 1. This means aero side guards are cost effective in mitigating the severity crashes, that is, reducing the fatalities of bicyclists and pedestrians who crash into the truck. Okay, there's additional information I want to point out. Volk, which was the agency that we contracted with to do the study, has not backpedaled, has not taken back their conclusions. All right. Their conclusions still hold validity. They still hold on to their findings, analysis, and conclusions. Why do we say this? Because in November 2022, they made a presentation in front of the British Columbia Injury Research and Prevention meeting, and they used the results of this report to make their presentation. And they did not change any of the numbers, did not change their conclusions or their findings. Okay, that ends my presentation. I'm sorry I went over about 5 minutes, but you may ask questions. Is anyone shocked by this?
A reminder for everybody, if you have a question you'd like to pose, use the hand emoji in Zoom, and Marianne will call upon you.
Matt, would you like to go ahead and ask your question? Matt Trunke?
Yeah, sure. Hi. I was just looking at the cost benefit analysis chart. The safety benefits seemed to lower after reaching a certain point. Is there any reason for that? Or is there a particular factor that's playing into that?
Well, as I mentioned before, that when you get all your trucks equipped with side guards, you're not going to gain anything. The only gain is from the new trucks that are bought that have the side guards installed. Do you understand that?
Gotcha. Yeah. Thank you so much.
It's not that the benefit itself increases. It's that you don't have any more trucks to put side guards on, except newly purchased trucks.
Okay, Alyssa, you had.
Hi, this is Elisa Braver. I had a number of questions, but one was whether the cost of preventing non-fatal injuries was factored into Volpe's analysis.
Non-fatal injuries.
Side underride guards presumably would not only reduce fatalities, but also reduce the severity of injuries.
That's a good question. I did not go into looking at the details of that. I think maybe they focused on the fatalities. I didn't.
Okay. Because that's
I didn't see numbers for injuries.
Yeah, that's a large part of the injury burden.
Right, I agree.
Okay, and of course, all of us are wondering about. You were talking about the skirts that provide protection for pedestrians and cyclists, but what about did you work at all on the costs of guards that would prevent both motorized vehicles and vulnerable road users from going into
did not. We did not. And well, we had to limit the scope of the study, and my main interest at that time, because of my cooperation with the Department of Energy, was looking at the synergistic effect of combining aerodynamic fuel savings with minimum safety.
And I was wondering what DOT told you in terms of their rationale for supporting the findings. I realize that what they tell you may be different from what the real reason was. I'm just interested in what they
When they saw a copy of the report, they told me those numbers are wrong. They're not using the right numbers. Okay. And I didn't know how to respond to them. I mean, I knew I was retiring and I didn't have to respond to them because it's another agency. It's, they're not my boss. So I just stayed quiet. But I believe that if they're going to suppress this kind of information, they must have a more ulterior motive. I mean, if you don't agree with another professional on the results, okay, we can talk it out. We can say, oh, let's look at the numbers again and let's recalculate using this number, or we relook at data, or we look at maybe the cost of the side guards are more expensive. No, they just wanted to suppress it.
Okay, so they didn't say, we disagree with you because of this, that, or this. They didn't say specifically, this is what changes they wanted or how the numbers were wrong.
No, they didn't go specifically into saying which numbers were wrong. They just said the whole thing's wrong.
Steve Bingham, you want to go ahead?
Yes, I just wanted to follow up on the question about injuries, and with a thought that the reasons they probably didn't even think of including injuries is that the federal government doesn't have any way to calculate that and tends not to do so. And my question is that in the work that we've been doing with forest data and learning how incredibly inaccurate and undercount prone it is, I'm wondering if there was any reference to the figures being used about the number of fatalities, and surmising that the number is probably significantly greater than the forest statistics, which I assume was what they were using. were
Yes,
showing.
I think they were using the FARS data. Now, I'm not an expert on traffic crash data, but all I can say is that we trust Volpe's analysis. Volpe has been a very trustworthy agency. We call them the think tank for transportation.
Thank you, Steve. Did you have any other questions? Okay, David Zuby.
Yeah, I guess I had two questions. One would be related to Steve's question, and that is, how the researchers at Volpe made the determination that a fatality involving a bicyclist or pedestrian was side under guard related? And the second question is related to Alyssa's question, and that is, in coming up with the benefits, was it assumed that all of the side guard related fatalities go away, or was there some fraction describing the efficiency of the guards at preventing fatalities used in that equation?
Okay, these are good questions. First, I think they looked at the individual reports, and there are a number of fatalities that they discarded. Any fatality that resulted in a point of contact with the rear or the front of the truck did not count, because these are side guards, not rear guards or front guards. Anything that hit the top of the truck, someone could have tried to commit suicide, hit the top of the truck and then bounced off and then get run over. They didn't count. Third, if a bicyclist or a pedestrian was killed by an object that was that flew off the truck, they did not count. In other words, a piece of metal or equipment, or maybe a wheel had gotten loose, hit the pedestrian fell down and then got run over, they did not count, because that's something that a side guard would not be able to prevent. Okay, so those kinds of things, those kinds of fatalities, did not count as being that could be prevented by a side guard. now I forgot what the second question was. Did they, was it injury related?
Well, was it assumed that all of the related fatalities would go away with side guards, or did they assume some fraction of representing the efficiency of preventing fatalities?
I think they assumed some percentage because there were countries, when they took the international data into account, there was some percentage of effectiveness. And they also used a percentage of effectiveness when it came to fuel saving. That's why they gave the range. I don't have those numbers with me. I have to go back and look in the final report.
Thanks.
Let me just add, for everybody whose questions turn to technical matters, that one of the significant things that Mr. Kwan's speaking out today will cause is the release of the final report. That is the full final report with its methodology statement and tables will be released as part of our action item that I'm hoping to get us to after your questions are done. So in just a couple of minutes, we'll discuss that if there are any further questions.
One comment I can make is that I don't think Volpe has been allowed to speak on this. They've made presentations on their own, but wherever you see one of their presentations, there's always a qualifying statement in the PowerPoint that says these are Volpe's findings, but they do not represent the Department of Transportation's official policy. So you can interpret that at face value.
I have a question. but
Okay, go ahead.
Is this the same formula I would use to calculate underride fatalities on with a truck that would have a side guard that would that would prevent a car from going under, such as an angel wing or a safety skirt one?
That's a good question. I would think so, but I'm not the cost benefit analysis that Dr. Alexander Epstein is. I would use the same formula. I don't see why not.
Thank you.